Today I'm going to tell you the most important things you need to know about energy and climate change. So, climate change is a issue that is affecting everyone on our planet. So, it is a global challenge. And what we need to do when we have a challenge like this that affects all of humanity, we have to understand the science, we have to have solutions to the challenge, and we have to have the social will to address those challenges. These are three key parts of the framework to actually have effective action on a global challenge like climate change. So let's start with the science of climate change. And first, I want to just take a step back and understand what the greenhouse effect is. So, the greenhouse effect is what allows us to live on planet Earth. We have an atmosphere that when the sun rays hit the Earth and that radiative light changes into heat when it hits dark places or water on the Earth, it radiates as heat, and greenhouse gases in our atmosphere trap some of that heat and allow us to have a much warmer planet than would be if we didn't have that atmosphere. And so that is the greenhouse effect. What we are doing when we are talking about climate change and human-caused climate change, we are adding greenhouse gases to that atmosphere and trapping more heat in the atmosphere than would just be there naturally with the greenhouse effect. So we're seeing the implications of that in our weather, our plant life, basically our life support systems on the planet. But the greenhouse effect is a very important part of why we're able to have the atmosphere, the livable planet we do. So if you look historically at greenhouse gases, and there's many ways that we track these, and we can track greenhouse gases in history, hundreds of thousands of years ago, often through ice cores and other things. You can see that the greenhouse gas, and we're tracking CO2 concentration here, goes up and down. And we understand this up and down pattern. It has to do with the wobble of our planet around the sun. And so sometimes we're close to the sun, sometimes we're further away. It's not just in terms of our annual or our daily rotations, but there's actually some wobble. And so you can see we've had this pattern of greenhouse gases going up and down, kind of aligns with ice ages. So when we get less greenhouse gases, we get ice ages, we get more greenhouse gases, it warms the atmosphere. What we can see with measurements for today is how stark the increase in greenhouse gas is compared to what we've seen over the last 800,000 years. And so when we're talking about human-caused climate change, it is due to this dramatic increase of greenhouse gas emissions and concentrations in our atmosphere following primarily the Industrial Revolution going forward. So when we talk about energy and we're talking about climate change in an energy system, it's because energy usage is the single biggest source of greenhouse gas emissions. We have other areas, agriculture, waste, things like that, that also contribute to anthropogenic greenhouse gases. But energy is by far the biggest contributor to greenhouse gas emissions, and that's primarily from the burning of fossil fuels or the leakage of methane that is contributing to those greenhouse gas emissions. We have already seen a significant increase in the temperature of our planet because of this increase in greenhouse gas emissions and concentrations in our atmosphere. We're up towards about 1.1 degrees C or 2 degrees Fahrenheit, but recognize that the greenhouse gas emissions that we've already had and we've already put into the atmosphere, it actually is a delay before we see the related temperature increase. So we've already built in a higher temperature increase than we can measure today by the greenhouse gas emissions that we've already put into the atmosphere. You've probably heard when we talk about what level of global rise in temperature that will cause some pretty catastrophic impacts on our planet. 1.5 degrees has often the limit of what we want to keep our temperature rise below. 2 degrees is where we'll really see a lot of catastrophic changes in our planet. And you can see how close we really are to that limit. And so we've been tracking this for a long time. These are just some different visualizations of the temperature increase that we've seen over time. The 10 warmest years on record have been the last 10 years. 2024 was like a step change year. We saw a lot of change 2023, 2024, both in global surface air temperature and sea surface temperature. Now, it's not uniform. And so when we look at our planet and what's most impacted by temperature change, it's actually the poles see the biggest change in temperature compared to the mid-latitude. So you all have probably been impacted or have had family impacted or countries that are impacted by climate change. This is with longer and hotter heat waves, droughts, hurricanes, wildfires that we see all over the world, coral bleaching events, sea temperature rise, mean sea level rise, and we're expected to see an increase in this as we lose some of that land ice as the glaciers are melting. And of course, that impacts some communities a lot. This is just a picture of the Maldives, which sea level rise is very impactful for island nations, for example, or coastal areas where a lot of people live. And those extreme weather events are increasing both in size and frequency. This is just one measure of that. And this is just measuring the dollar of events in the United States. And you see this dramatic increase in these extreme weather events, much of which are the climate change is contributing to the frequency and the extreme of those events. All right, so that's the science, and we know that that science is happening. Now we have to talk about both the solutions and the social will, the gaps. So there's been a lot of effort at the global level to take the science and put it into policy and implement those policies or pledges. But what we see is the policies in action do not get us to where we need to be. The pledges and targets, even from countries, are not where we need to be, especially if we're thinking about 1.5 degrees, or I think today we're thinking even more about 2 degrees C in terms of that global temperature. And so we call this the ambition gap. We're not pledging to where we need to be in order to keep some of these more catastrophic events from happening with climate change. In the United States, we have a particular challenge with the social will part of this solution. So, although the science of climate change is settled, it's actually kind of rare to see scientists so in agreement on an issue. But in terms of like the American public, the social will, it does not match what scientists have. But we only have a limited carbon budget, and it is a global carbon budget. What does that mean? We only have a certain amount of greenhouse gas emissions or CO2 equivalents that we can put into the atmosphere before we get to these levels and see this catastrophic event. And so this is just a visualization to kind of help you think about the carbon budget of our planet, making it a bathtub, because we can all kind of picture a bathtub, right? We've got natural carbon cycle where we have sources of carbon or greenhouse gas emissions. We have sinks for greenhouse gas emissions like our oceans, our soils, our forests. And this is a natural cycle of our carbon. And then we have the human emissions tap. So we're just adding with our greenhouse gas emissions. We're not doing a lot to take carbon out of this. You might hear, we can look at our talk on carbon management. But so we really have to do is turn off the tap from human emissions to really have an impact on climate change. And we've got to do it quickly. The energy transition for 2 degrees to get to net zero is even pretty steep. 1.5 degrees seems pretty challenging to actually get there. So we really have to decarbonize quickly. One of the challenges that comes in when you were thinking about, so we have science, solutions, and social will, is how do we allocate responsibility? Because it does take investment in decarbonization of our systems in order to address climate change. One way you could think about allocating responsibility is on who's emitting the most every year. China's the biggest, the largest emitter today in terms of greenhouse gas emissions. But you could also think about it in per capita. Per capita emissions, Australia and Canada and the United States are the three largest emitters every year. And you could also think about it historically in terms of cumulative carbon emissions. Oftentimes, this one is pointed to because Europe and the United States have been emitters of greenhouse gas emissions for a long time through the Industrial Revolution, and those countries have benefited from the economic development from the emission of those greenhouse gas emissions. And so a lot of times on the international stage, a developing world is saying, hey, you've benefited from this, you have more responsibility to invest in the decarbonization and the economic growth of the developing world that hasn't contributed as much to this problem over time. One of the ways we think about greenhouse gas emissions and how do we address them is measurement and understanding the sources of the problem. So as a business or an entity, as Stanford University, we think about how much control we have of different emissions. We put those into scope. Scope 1 basically means this is our emissions that happen at my business, on my campus. I have a lot of control over Scope 1 emissions. Scope two, we also have a lot of control over as a business or supply chain or something, because that's from our purchased electricity, heat, and steam. Scope three is much harder to address, but it is just as important as we're thinking about greenhouse gas emissions globally. And that has a lot to do with supply chain, about how employees get to work. It's kind of like everything else that's not directly under scope one and scope two. Much harder to measure, much harder to address, but also very important to think about addressing the problem. The investment in our clean energy sectors, so we're talking about solutions now, and how do we decarbonize, is growing. And so I didn't want to leave us on a note that, all the bad things that are happening from climate change, it is urgent, it is real, but what we can do about it, we have lots of solutions. We have to put the investment towards them. Investment is happening. It's just how fast is that investment going to happen? One of the big things is to electrify everything. You may have heard about this. This gives us the opportunity to improve the efficiency of our end uses and to decarbonize those end uses. So that's transportation, that's our heating and cooling systems, that's our cooking systems. If we electrify those, it gives us the opportunity to decarbonize those systems and have an impact on the reduction in greenhouse gases. And finally, I just want to give you a sense that although a lot of the future might look like we're not changing things fast enough, and we really aren't, but we also underestimate our capacity for change. So what I'm showing you here is what the IEA estimated for solar additions every year and what actually happened. So we do have the capacity to change quickly. We just have to take that social will and put it towards those changes. So the real question is, how fast can we make this transition happen? I firmly believe we will get to a clean energy future. There's all sorts of reasons we would do that, economic and health and climate change reasons. It's just how fast will we get there? What will the damage be like in the meantime? So if you want to do things, we do have a website called Decarbonize Your Life, which you can go check out. System level change is crucial. Voting, thinking about climate change, talking to your friends, your colleagues about it, putting pressure on policy leaders, considering it in your workplace. But I find also individual actions, although they don't move the needle by themselves, they are an opportunity to learn and share. And you see spillover effects with family, friends, colleagues when you make those individual actions. Personally, I also find I learn a lot about how easy or hard an action is. And that makes me more informed when I'm having these kind of system level conversations. Okay, that was our 10-minute take on energy and climate change. Please go check out the lecture online if you want to see the full energy and climate change lecture.